Let's analyze the merge sort process. It uses the divide and conquer and a recursive approach to do this, repeatedly dividing into half, into half, into half, until we're just looking at two individual items, and then it starts merging them back into one list. And finally, we have a sorted array for the entire list. The problem with the merge sort is that it uses twice as much memory for a temporary storage array that's used in the process. Here's the pseudocode for the merge sort, at least the first part of it. Merge sort is called with the original list, which is passed by reference, and then a new temporary list is created the same size as the original list. Those two lists, as well as a front and back marker, are sent to a method called merge sort helper. That is then processed to continually divide the list in half. Now, this will only divide a list in half if there is a list of at least two elements. As long as the front is less than the back, which means at least two elements, then we find a middle, we divide it into the left side and the right side. And then we start merging them back. This requires 5 parameters, the two lists, as well as the front, middle, and back of this current list. Then 3 variables are used inside of merge. One to mark the front of the left side, one to mark the front of the right side, and this marks the front of the temporary. This while statement says, as long as I have something in both lists, they're not completely empty. Then I compare the front value of the left with the front value of the right and put the lesser one in the position. This will put the left front value into the temporary list, and then I takes a step. This one will take the front value of the right side, put it into the temporary, and then that takes a step. That will take a step regardless. When this process is finished, that means that one of the two sides is completely empty. There's still stuff in the other one though. So we have to clean up. This will clean up the left side, and this will clean up the right side. Study that part very carefully so that you completely understand what's going on there. Finally, all of the values in the temporary list are dumped into the original list, and we finally have a sorted array. The analysis for this is quite easy. Because of the divide and conquer process, it's a log n. But since we have to visit every single node, it's an O of n. So those two combined make it an n log n process. Now, it doesn't matter what the original nature of the data is, whether it's sorted or random or reversed. It doesn't look at any of the values until the merge sort process works. And it's going to work the same way regardless. The basic analysis of the merge sort is an n log n process. And you need to study the animation and the code until you completely understand the nuts and bolts of this idea.